مستمعين. Today inshallah we will solve some examples and exercises about discrete probability distributions in general. So the first example, computing the mean and standard deviation of discrete random variables. SSS is a company that sells and installs home security systems throughout the eastern United States. Each week, the company's quality managers examine one randomly selected security installation in states where the company operates to see whether the installers made errors. So he examines one security installation, searching for errors. The discrete random variable x, yeah, he needs to define x for me. The discrete random variable x, what is the definition of x? The number of errors discovered on each installation examined. Okay, so each week he will examine a security installation and the number of errors would be recorded. All right, ranging from 0 to 3. So the errors cannot be more than 3, cannot be less than 0. So what are the possible values of x? 0, 1, 2, 3. The following frequency distribution. Notice this is a frequency distribution. It is not a probability distribution. There is a difference. What is the difference between frequency distribution and probability distribution? In this column, here you have frequency. In the probability distribution, you will have relative frequency or probability. The following frequency distribution was developed after an examination of 400 security installations. So the total, the sum of the frequencies is 400. Assuming that this data reflect typical performance by the installers, the company leadership wishes to develop a discrete probability distribution for the number of errors, okay, and compute the mean and the standard deviation for the distribution. So first, we need to develop a discrete probability distribution. This is not a discrete probability distribution. This is a frequency distribution. So how can we develop a discrete probability distribution? We find the relative frequency, or we can call it the probability of x. So how do we find the probability of x or the relative frequency? I have to divide 150 each number by the total. So if you divide 150 by 400, you get 0.375. So this is the probability of 0. If you divide 110 over 400, you get 0.275. So this is the probability of 1. Probability of 2 is 0.125. And probability of 90, you can find probability of 90 by two methods, either by dividing 90 over 400 or by adding these probabilities and subtract from 1. Okay, so the sum, the total should be 1. The sum of all probabilities, check and it is 1 to make sure that your answer is correct. Now, having the possible values of x and the probability of each x, we having a discrete probability distribution. All right. Now the next step, find the mean of this distribution. So the mean or the expected value of x is defined to be summation x bx. So you multiply each number by its probability. So 0 times 0.375 plus up to 3 times 0.225. And then you find the answer. You can use the calculator again. You can use mode stat if you like. And you enter the numbers 0, 1, 2, 3, and you put the frequencies, the probabilities in place of frequencies in the calculator. So 0.375, 0.275. Please, you can try with me if you have a calculator. Try to solve the question with the calculator to get used to it. And then you press on and then shift stat and you ask for variance and number 2x bar, which is mu in this case 1.2. So the expected number of errors is 1.2. This is the expected number of errors every time he checks the installation. Okay. Now, how to find the standard deviation? Well, I will find sigma square first, which is the variance, which is by formula summation x minus mu square times probability of x. So it would be 0 minus 1.2 square times 0.375 plus, and the last one is 3 minus 1.2 squared times 0.225. And you can evaluate this by the calculator and write the answer. If he asks you to compute, you can do this. Okay, you can write these steps exactly, but please fill in the blanks. Okay, just fill here in the blanks. And then you can go to shift stat for variance. Number 3, you choose sigma because we are talking about populations. And notice that what the calculator will give you is the standard deviation. So you have to square it if you need the variance, like here. So 1.36. And then he asked you for the standard deviation. So you should say that standard deviation is sigma equals. So you have to tell him that you know that sigma is the standard deviation and not sigma square. Square root of 1.36, and then you write the answer, which is 1.166. So this is the standard deviation and the mean of this probability distribution. Another example, given the following discrete probability distribution, calculate the expected value of x. So please, I leave this for you. You can do it by yourself. You can add here, if you like, x times p of x. You can add a column, okay? And you can write x times p of x. And the total here at the end, here the summation is 1. Here the summation would be mu. The sum here would be mu. And to find the variance, you can find x minus mu squared, column for x minus mu squared, if you like, and then column for x minus mu squared times p of x, if you like. Okay. And here, the sum here of this column will give you the variance, sigma square. All right. This is if you want to use columns. So please calculate the variance, calculate the expected value, and take the square root of the variance and give him the standard deviation of x. Now, let y equals x plus 5. So there is a new variable called y, okay, not x, and the definition of y, x plus 5, okay. So x, for example, is 50. So y would be 55. X is 65, 70. 70 would be 75. So you are just adding 5 to each value of x. I have 75, it would be 80, and I have 90, I believe. So it would be 95. So these are the values of the new variable y. The probabilities remains the same. The probabilities did not change. So the probability of y are the same. So 0.375, because he did not say anything about it. 0.15, 0.225, 0.05, and 0.2. The sum of all of these probabilities should be 1. Now, what is the question? Calculate the expected value of the new random variable y. So I leave it for you to find mu here. What would be mu, which is the expected value of y, okay? What would be mu in this case? And then when you find ey, you will see, will it be plus 5? Yani, could it be the same mu here plus 5? Okay, check that. I think it would be mu plus 5. Also here, another experiment. Do this experiment at home, please. Define a new variable z, but this time it is 5 times x. So you are multiplying each x by 5. So 50, for example, would be 250. Okay. Continue like this. And the probabilities does not change. The probability is always the same. 375. Okay. Up to 0.2. And find the expected value of this random variable, Ez, and check whether is it going to be 5 times the EX. Is it 5 times EX? Okay, find out and tell me, please. Here, is this EX plus 5? Okay, check it, please, and tell me whether this is true or not true. Okay, another question. 2 6-sided dice are rolled 2, and the random variable x, yeah, what is the definition of x? Always he needs to define x, is the sum of the values produced by each die. The sum of the values produced by each die. You have 2 dice, so you can say that the first die will give you 1, 2, 3, 4, 5, 6. These are the possibilities of the first die, and the possibilities of the second die is this. Okay, this is the experiment. And one outcome, for example, here the outcome would be 1, 1. You can write it like this: 1, 1. Here 1, 2, and so on up to 6, 6. So in fact, we have 36 possible outcomes of this experiment. In the sample space, we will have 36 outcomes. Okay. From 1, 1 to 6, 6. All right. Now, what is the definition of x? X is sum of values. Okay. So what would be the possible values of x? If you add 1 plus 1, you get 2. So you will not have 1. There is no 1 because there is no 0, 1. The smallest value of x would be 2, and it comes from 1, 1. What about 3? 1 plus 2, it is there. 1 plus 3, 4. 1 plus 4, 5. 1 plus 5, 6. 1 and 6, 7. Okay. Up to what? Up to 12. Because 6 plus 6 is 12. So all of these are possible values of the variable, the random variable x, which is defined by the sum of the values for the 2 dice. Now the question, determine the probability for each outcome. what is the probability of each for each outcome? We have 36 outcomes. Probability of each outcome would be 1 over 36 because this experiment is equally likely. All the numbers have the same chance to appear. So 1 over 36, this is the probability of each outcome. And calculate the expected value of x. Now we need to find the probability of each x, okay, to have a discrete probability distribution. So for 2, now you start to count how many times the sum would be 2. It would be 2 only from 1, 1, okay? So the probability of 2 would be 1 over 36. But you will see 3, 1, 2, and 2, 1. So you have 2 over 36. You will see 4 from 2, 2, 1, 3, and 3, 1. So the probability of having sum of 4 is 3 over 36. 5, you can see 5, 1, 4, 4, 1, 2, 3, 3, 2. So 4 over 36. You can see 6 by 1, 5, 5, 1, 2, 4, 4, 2, and 3, 3. So 5 times 5 outcomes. 5 outcomes will give you the sum of 6 when you add them. 7, you can see 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. So you will have 6 possibilities to see the sum of 7. 8, you can see 8, 4, 4, 5, 3, 3, 5, 2, 6, 6, 2. Okay, there is no 1, 7 because 7 is not there. So 5 possibilities. You can see 9 from 4, 5, 5, 4, 3, 6, 6, 3, and that's it. So you have 4 over 36. You can see 10 from 6, 4, 4, 6, and 5, 5. So 3 over 36. You can see 11 from 5, 6, 6, 5. And you can see 12 only from 6, 6. Now, if you add all of these numbers, you should get 36 over 36. 3, 6, 10, 15, 21, 26, 30, 33, 36. So this is a complete probability distribution of this experiment. Now, what do we need to do? Calculate the expected value. So I leave this for you. You can find the mu, which is summation of x, p of x. Please do it, find the answer. Use the calculator or don't use the calculator and just give me the answers. Write here, if you want to use the calculator, at least write 2 times 1 over 36 plus up to 12 times 1 over 36 and find the answer. Calculate the variance, sigma square. Okay, can do it. Please also find the answer. And the standard deviation. Okay. Now another question, determine the proportion of the distribution that's contained within this interval. Okay. Now what is this interval? Let us find the mean and the variance for this example using the calculator quickly to answer the following questions. The calculator can give you the answer, of course, faster. You put the probabilities in place of frequencies. I hope I don't do mistakes. Please check it at home. Okay, then you press on, and then I ask for shift stat, and mu is 7. Well, 7 is expected, yani, because it has the most probability. Okay, and we have 5 numbers below 7 and 5 numbers above 7. So 7 is expected, really. So this yani says that our answer is correct. And you find 3, which is the standard deviation. Okay, standard deviation is called sigma. You call it sigma, and it is 2.415. And if you square it, you get the variance, which is 5.83333. Now, how to construct these intervals? Simple. Mu minus sigma would be mu is 7 minus 2.415 and 7 plus 2.415. This is the first interval, if you remember, when we studied the empirical rule and Chebyshev theorems. So 7 minus 2.415 is 4.585. And if you change minus to plus, 9.415. So this is the interval, mu plus or minus sigma. Now, what is the question? Determine the proportion of the distribution that's contained here. Okay, so what proportion of the distribution is contained here between 4.5 and 9.4? Now go to the values of x. Go to the values of x. We need it to be greater than 4.5. Okay, so I can start from here. 5 would be included, but 4 will not. 9 point something, so 9 would be included. So you can say that in this interval, I have, because this is 4, and this is 9, and this is 10, and this is 5. I need it to, the interval is from 4.5 to 9.4. Okay, so I will have these numbers, which is 5, 6, 7, 8, 9. All of these numbers belong to this interval from 4.6 up to 9.4. Okay, so the question, determine the proportion. So proportion of the distributions would be probability of 5, this, okay, these numbers, these probabilities. 4 plus 5 plus 6 plus 5 plus 4. So would be 4 over 36 plus 5 over 36 plus 6 over 36 plus 5 over 36 plus 4 over 36. 2, 5 numbers, 5 probabilities or proportions. If you add them, 15, 20, 24 over 36. So the proportion or the probability is 0.6666. Okay, you can write it 0.67. So 67% or 0.67 of the distribution will lie in the first interval. You remember? Do you remember the empirical rule? Empirical rule says what percent of data lies in the first interval? Approximately 68. It's 67. It's close to 68. Okay, approximately 68. We have 67 of the data lies in the first interval. Please do at home, continue the question. You can find the interval, mu plus or minus 2 sigma, and check in that interval what proportion of the distribution lies in the second interval, and you can also check the third interval. This is the end of section 5.1, and inshallah tomorrow we start